We often forget what an amazing technical achievement cars are. They burn fuel by reacting it with oxygen in small explosions that are initiated by a spark plug. Each explosion gives off only a small amount of energy, but the engine carries out hundreds of explosions every second. This allows a car to accelerate from 0 to 60 miles per hour in under 2 seconds. Well, that's a race car. My car, closer to 10 seconds. And if I'm driving, more like 2 minutes. A bomb calorimeter allows us to measure the energy released by a single such explosion. This is real chem. In thermal chemistry, it's all about keeping your eye on the energy. Energy is conserved. It doesn't just come from nowhere, and it doesn't just disappear into some void. If a chemical reaction releases energy as heat, that energy has to go somewhere. In calorimetry, we capture the energy and find ways to measure it. Let's explore. A bomb calorimeter is ideal for measuring the energy released by a chemical reaction, such as that occurring in the internal combustion engine of a car. Let's use a bomb calorimeter to determine the energy released by each of the explosions that occurs in a car. First, we will use the calorimeter to determine the energy released per gram of auto fuel. To do this, we'll put 1 gram of fuel into the metal container at the center. We then add an excess of pure oxygen gas and use an ignition coil to initiate the combustion reaction. Boom! Most of the heat generated is transferred to the large body of water, 750 grams of water, that surrounds this central container. We find that the temperature of the water increases by 11.4 degrees. We can determine the amount of energy transferred to water using Q is equal to mc delta T. M is the mass of our water, 750 grams. C is the specific heat of the water, 4.184 joules per gram degree. And delta T is the temperature increase of 11.4 degrees. This gives us 35,700 joules of energy transferred into the water. But not all of the energy generated from this reaction went into the water. Some also goes into the calorimeter apparatus. The metal, the insulation, the thermometer, everything. In calibrating the instrument, it was found that it takes 990 joules to increase the temperature of the apparatus by 1 degree. The heat capacity of the apparatus is then 990 joules per degree. The water went up by 11.4 degrees, and the apparatus is in thermal equilibrium with the water, so it also went up by 11.4 degrees. The energy transferred to the apparatus is then 990 joules per degree times 11.4 degrees, or 11,300 joules. The total energy released by the reaction is the sum of that transferred to the water and the apparatus, or 47,000 joules. This is the energy from burning 1 gram of fuel. However, each explosion in a car burns only about 0.02 grams of fuel. So each explosion generates 47,000 joules per gram times 0.02 grams, or 940 joules. This is not a lot of energy, but even a small car can carry out 4,000 explosions each minute, giving us 3,760,000 joules of energy every minute. That is more than enough energy to get from 0 to 60 miles per hour. A bomb calorimeter allows us to accurately measure the energy released by a reaction. It does this by ensuring that all of the energy released goes into changing the temperature of the calorimeter. Of course, in a car, the goal is entirely different. Instead of the energy being used to heat the car, it's used to move the car. So, explore, and remember to have fun.